In terms of multiplication, when we're multiplying these things, if I want to multiply radical terms, basically I follow the same rules kind of like I do with variables. Again, when I'm dealing with variables and I multiply the numbers out front, I multiply the coefficients, and then I multiply the variable portions together and I deal with the exponents. Well, here it's going to be the same thing. I'm going to multiply the coefficients and leave the product on the outside of the radical, and then I'm going to multiply the radicals together. I'm going to treat them separately. So when I multiply the radicals, I multiply what's underneath there, and I leave it under the radical. All right, and so the easy way to remember this is basically what's on the outside gets multiplied with what's on the outside, what's on the inside gets multiplied with what's on the inside. All right, and we go back to that analogy I had about, being a radical is like being in prison. So again, the things that are they're both inside the radical, they can associate with one another. They can hang out, lift weights in the yard, maybe play some basketball, and then the things that are on the outside have to stay separate from that. Okay, stuff on the outside with stuff on the outside, stuff on the inside with stuff on the inside. And then the last thing we do is just make sure we simplify everything completely. All right, so we want to simplify those radicals in the end. All right. For example, when I look at something like this, again, I've got to keep these things separate. This 5 can't just jump in here with the 2, and this 4 can't just jump in here with the 6. So that means this 5 can't jump over here and multiply with the 6, and this 4 can't deal with this 2. We have to keep these things separated. So when we do that, we basically say, okay, stuff on the outside, stuff on the outside, so the 5 times the 4, and the 5 times the 4 gives me a 20. Stuff on the inside times stuff on the inside. So the stuff on the inside was the 2 and the 6. And when I multiply a 2 and a 6, it gives me a 12. Okay, so this is basically what I get when I multiply these out. I get 20 square root of 12. Again, I multiplied the outside together, I multiplied the inside together, and they stay where they were. But now the last thing I do here is I just try to simplify this a little bit. I don't want to leave that as the square root of 12, because the square root of 12 I can break down into a 4 times 3. See, I'm breaking this down to perfect squares. The square root of 4 is a 2. It goes to the outside and it multiplies. That gives me a 40. And then the 3 is still trapped. So it's 40 square root of 3. All right. So we're just adding a little bit of an extra step. We're still working on that simplifying stuff. But again, we multiply the stuff on the outside with stuff on the outside, inside times inside. And that's it. All right. If I look at the next one, again, stuff on the outside, I've got the 9 and the 6. And when I multiply those, it gives me a 54. I look at the stuff on the inside, I've got the 10 and I've got the 5, and when I multiply those it gives me a 50. And so now what I'm left with here is I've got the 54 square root of 50. Well, now I just want to simplify this thing completely. So perfect squares that divide evenly into 50, that's going to be a 25 and a 2. And now I can take the square root of 25. The square root of 25 is a 5. It goes to the outside as a change number on the outside. And again, it's going to multiply by that 54. And so when I do the 54 times the 5, that gives me a 270, I believe. And then the 2 is still trapped. That's it. All right. So again, outside times outside, inside times inside. And then we simplify. For this one, I don't have anything on the outside, or, well, I can consider the fact that I have a 1 on the outside, but 1 times 1 is just 1. So I just have stuff on the inside, so I multiply the insides. And when I do this, this is going to give me a 720. This is going to give me an x to the 4th, and this is going to give me a y to the 5th. And now from here, this might be pretty tough to see what's gonna simplify here and how I'm going to simplify this thing. And so when I try to simplify this, it might be a little tough to see that there's a 36 that divides evenly into this thing. See, this is going to be a 36, and it looks like maybe, let's see, the 36 times 20, and actually I can break that 20 down further, and you can see the problem we run into here. I can break this into y to the 4th times y, and then from there I can start taking the square root. But you can see this might take me a couple steps here. That's going to give me a 6, an x to the 2nd, and a y to the 2nd, and then the square root of 20y. But now I can break that down a little bit further here. And again, this is problematic because of the size of the numbers that we're in here. That 20 I can break down into a 4 times 5. And I'm just doing this real quickly off to the side. The square root of 4 is going to come out as a 2, so that's going to give me a 12x squared y squared, and then the square root, there's going to be a 5 and a y left. All right. And the thing that makes this one difficult is the size of the numbers I was dealing with. So let me try this one again. If I hit the reset button here, I'm going to leave just the answer that I had. when I look at this thing, instead of multiplying right away, what I can do is I can simplify each of these as much as I can, and then I can do the multiplication. So in this one, I might break this down into a 36 times 2 to start, and then an x squared and an x, and I leave the y squared the way it is. Times over here, the 10 I can't really do anything with, the x I can't do anything with, but the y to the third I can break down into y squared times y. And now again, I'm taking the square root of the numbers. That one gives me a 6. The variables I'm dividing by 2, so I end up with an x and a y. And then what's under my square root is the 2 and the x. Over here, I can take the square root of the y squared, that's about it. So that's going to leave me with a y and then a square root of 10xy. And now from here I can do some multiplication. When I multiply, that gives me a 6xy squared on the outside. Inside I get that square root of 20x squared y. And now I can go from here, I can break this down and say, okay, this is a 6xy squared. The 20 I can break down into the 4 times 5. The x squared's already fine the way it is, and the y I can't do anything with to begin with. Now I take the square root of each of these things. The square root of 4 is a 2. When it goes to the outside, I multiply and I get the 12. The square root of x squared is an x, and I multiply and I get the x squared. And then I can see that the 5y is still left. So I still arrive at the same answer, but maybe the numbers were a little bit easier to deal with, okay? So it's really up to you whether you want to multiply first and then simplify, or if you want to simplify a little bit first and then multiply, okay? And it's the same thing with the next one. Again, I can simplify this first and then go from there. Or I can multiply first and then simplify. I think it's going to be easier to simplify a little bit first. So when I simplify this one, again, I'm going to break this down into a 9 times 5. The x to the fifth, I'm going to break down to x to the fourth times x. And the y to the third, I'm going to break down into y squared times y. Over on the other side here, the square root of 35. The 35 I can't really do anything with, so I'm going to leave it the way it is. Then I've got the x, and the y to the fourth is already fine the way it is. And now I can start taking the square root of each of these things. So here I take the square root of 9, that gives me a 3 on the outside. And then I take the square root of the x to the fourth, that gives me an x squared. And then I take the square root of y squared, that gives me a y. And again, we're gonna ignore the absolute value symbols for now. And then on the inside, I'm left with the square root of 5x and a y. For the other one, when I do this guy, I can't do anything with that square root of 35. The only thing I can take the square root of is the y to the fourth. That gives me a y squared. And then the square root of 35x is still left underneath there. And now from here, let me scoot this guy up just a little bit. From here, now I can go ahead and do that multiplication. So I'm going to multiply what's on the outside by what's on the outside. That's going to give me 3x squared y to the third. Underneath, I get the square root of. This is going to give me what looks like a 175. And an x squared y. And now from here, I can simplify this a little bit. I've got a 3x squared y cubed on the outside. Underneath here, I can break this guy into a 25 times 7. The x squared's already perfect the way it is. The y I can't do anything with. And now I take the square root of each of these guys. And so this thing simplifies. The square root of 25 is a 5. It goes to the outside and multiplies. The square root of x squared is x and goes to the outside and he multiplies. And then the y cubed was already out there, and I'm left with the square root of a 7 and a y. Okay, so a lot of simplifying here, and again, 90% of doing this problem, the most difficult part is simplifying. So it's more of the same of what we were doing before. It's just a little bit more practice with what we were doing before. Okay, let me scoot all this out of the way just a little bit to give myself a little bit more room for the next problem. And when I look at the next one, again, this time it's a cube root. Again, the cube roots are so much more difficult just because we're not used to dealing with those numbers. So now with cube roots, in terms of the values that are underneath here, the 16 I can break down into an 8 times 2. Now I need variables that are exponents that are divisible by 3, so I'm going to break this into x to the 6th times x. The y squared I can't do anything with. There's no way I'm going to make that divisible by 3. And then this one I've got the cube root. I'm looking for perfect cubes that divide evenly into the 40. And as I'm looking at that, really the only one I can see is 8. So 8 again. So I've got 8 times 5. The x to the 4th I can break down into x to the 3rd times x. The y to the 4th I can do the same thing. Y to the 3rd times y. And now I start taking the cube root of each of these things. So I take the cube root of 8, the cube root of x to the 6th, and that's going to give me a 2 on the outside, and then an x to the 2nd. Because remember, I divide the exponents. I've got the cube root, I've got the 2, the x, and the y squared. In the next one, I take the cube root of each of these. The cube root of 8 gives me a 2. The cube root of x to the 3rd is an x. The cube root of y to the 3rd is a y. And then underneath my cube root, I've got the 5, the x, and the y. And now I'll do the multiplying. On the outside, it's going to give me a 4, an x cubed, and a y. And then under my cube root, when I multiply those, it gives me a 10, an x squared, and a y cubed. And as I look at what's underneath here, if I want to simplify this a little bit further, the 10 I can't really break down into anything. The x squared I can't break down into anything. The only thing I can do is take the cube root of this y to the 3rd. And when I do that, it leaves me with a 4x cubed. The cube root of y to the 3rd is a y, so it goes to the outside and multiplies with the y that's already out here, giving me a y squared. And then under my cube root, I still have the 10 and the x squared. And that's it. So again, the multiplication part here is very, very simple. The thing that causes us trouble is really the simplifying, the thing that we've been struggling with already. All right. And when I look at these last two, really, there's not too much of an explanation for this, but as I look at something like this, if I have a value, any value on the outside of parentheses, I know that in order to do this multiplication, I'm going to distribute. So I'm going to use my distributive property here. But applying this to radical symbols, I still do the same thing. When I multiply these first two, I do outside times outside, inside times inside. So when I do that, I do the 2 times the 5, which gives me a 10. I do the 3 times the 2, which gives me a 6 under my square root. And then I do the same thing with the next one. I do the 2 times the negative 4, which gives me a negative 8. I multiply the insides, which gives me an 18. And now from here, I just try to simplify this as far as I can. The 6, there's no perfect squares that divide evenly in there. The 18, I can break that into 9 times 2. And now right here, the square root of 9 gives me a 3. It goes to the outside and it's going to multiply. So this first part stays the same. That 3 comes out and multiplies. That gives me a negative 24. And then the square root of 2. And that's it. So again, simplifying is the biggest part of this thing. That's where this is going to become tricky, all right, is when we're simplifying these things. And then when I look at this last one, again, using my distributive property here, so I'm going to distribute this guy. And again, outside times outside, that gives me a 24. Inside times inside, that gives me a 16. On the next one, outside times outside gives me the 42. Inside times inside gives me the 10. And now I just simplify. This guy's already a perfect square. The square root of 16 is a 4. It goes to the outside, and he multiplies. So I do that 24 times 4, which is going to give me a 96. The other one, the square root of 10, I can't really do anything with because there's no perfect squares that divide evenly in there. And so that's it. All right, so again, we're applying the same rules that we've always applied, but when I'm dealing with radicals, I do the stuff on the outside times the stuff on the outside. All right. So to summarize here, again, addition, we're just combining like radical terms, have to have the same radical and the same radicand. Multiplication, outside times outside, inside times inside. The big deal here is really just the simplification of these radicals. So we got to keep practicing that so we can get good at it. And once you're really good at that, these problems become a piece of cake. All right?